Hi children, in the last class we discussed about series combination and parallel combination of resistors. Am I right? What is series combination of resistor? We have drawn a electric circuit. That is, in series combination, the current remains constant and the voltage varies. What is the resistance of series combination? R is equal to R1 plus R2 plus R3. And in parallel combination, the current does not a constant. It varies and the voltage remains constant. Okay, then what is the total resistance in a parallel combination having resistors R1, R2 and R3? That is 1 by R is equal to 1 by R1 plus 1 by R2 plus and 1 by R3. Okay, hope you clear that. Then we move on to the next section, that is also related with the parallel combination and series combination, that is advantages of connecting electrical devices in parallel combination. What are the advantages on connecting electrical devices in parallel combination instead of connecting them in series? Or what are the disadvantages of a series circuit? Okay, we will discuss. In the first point, here we discussing about the advantages of parallel combination, or we can say that disadvantages of series combination. Combination. This is our topic. First point is, in parallel circuit, if one electrical appliance stops working due to some defect, then all other appliances keep working normally. But in series circuit, if one electrical appliance stops working due to some defect, then all other appliances also stop working. How it happens? That is, in parallel combination, how can we draw the parallel combination of resistors? Simply we can draw a parallel combination of resistors of three resistors. Okay, these are the three resistors and a battery is connected. A voltmeter is here and a ammeter is here. Okay, this is R1, R2 and R3. This is parallel combination. Okay, then series combination R1, R2, R3. Here the ammeter is connected and an electric cell. The voltmeter is connected in parallel. Okay, this is the voltmeter. Then R1, R2, R3. Okay, this is the series combination. Here the first point is, in parallel circuit. In parallel circuit, if one electrical appliance stops working, if any one of these three resistors stop working, suppose if R1 stops working, it will not work. Then R2, R3, does R2 and R3 works? Yes, the R2 and R3 works. It does not affect the defect in the R1 does not affect the R2 and R3 because it is three branches. Okay, so in parallel combination, if any one of these three resistors have a defect, it will not affect the other resistor. If R1 has a defect, it will not affect the R2 and R3. Okay, but in case of series combination, If one electrical appliance stops working due to some defect, it will affect all other appliances. Okay, if R1 does not work due to some defect, it will affect R2 and R3. R2 and R3 also will not work. So the parallel combination and in series combination, this is the first advantages of parallel combination and disadvantages of series combination. That is, in parallel circuit, if one electrical appliance stops working due to some defect, then all other appliances keep working normally. In series combination, if one electrical appliance stops working due to some defect, then all other appliances also stops working. Okay, then the next one is, in parallel circuit, each electrical appliance gets the same voltage as that of the power supply line. We know in a power supply line, that is electrical transmission line, into our home, the electrical power supply line has a potential difference or voltage of 230 volt. Therefore, this 230 volt is constant. In parallel circuit, we know the voltage is same here. That is, the voltage is constant in parallel combination. That is, always this 230 volt is supplied in parallel combination. But in series combination, the voltage is varies. The voltage is varying. In parallel combination, the voltage is constant, and in series combination, the voltage is varying. When we connect the electrical appliances in parallel combination, it gets the same voltage as power supply, that is 230 volt. But when we connect in series combination, it does not get same voltage, that is the appliances do not get the same voltage as that of the power supply line. Okay, hope you clear that. Then the third and last point is, in parallel connection of electrical appliances, the overall resistance of the household circuit is less, due to which the current from the power supply is high. That is, in parallel combination, we know the resistance of parallel combination is 1 by Rp equal to 1 by R1 plus 1 by R2 plus 1 by R3. In case of series combination, Rs is equal to R1 plus R2 plus R3. These are all we studied. That is, when comparing the resistance of parallel combination and series combination, we have studied that the resistance of series combination is high and the resistance of parallel combination is comparatively low. That is, here the resistance is adding up. Okay, when we take the same value of resistors R1, R2, R3, we get high value for Rs and small value for Rp. That is, the resistance is very high. Okay, but here the resistance is very low. In parallel combination, the resistance is very low. In series combination, the resistance is very high. So, what about current? That is, the current, we know that as resistance increases, the current decreases, and the resistance decreases, the current increases. That is, so here the resistance decreases, so the current increases. Here the resistance is less, so the current is more. Here the resistance is more, so the current is less. Okay, so here more current is supplied. In parallel connection of electrical appliances, the overall resistance is less, due to which the current from the power supply is high. Here we get more current, but here we get less current. This is the advantages of parallel connection and disadvantages of series combination. Then we can do some problems relating to series combination and parallel combination of resistors. The first problem is, draw a schematic diagram of a circuit consisting of a battery of 3 cells of 2 volt each, a 5 ohm resistor and an 8 ohm resistor and a 12 ohm resistor and plug key, all are connected in series. That is, draw a schematic diagram. Here we have to draw a diagram of electric circuit. It consists of a battery. It consists of a battery consisting of 3 cells. Battery consisting of 3 cells, and each cell has 2 volt. One cell has 2 volt. Then 3 cell has how much volt? That is 2 into 3, that is equal to 6 volt. Okay, clear? Then there is a 5 ohm resistor. There is R1 is equal to 5 ohm, and an 8 ohm resistor, that is R2 is equal to 8 ohm, and a 12 ohm resistor, that is R3 is equal to 12 ohm. These are connected in series. That is, these R1, R2, R3 are connected in series. How to draw the diagram of this circuit? That is, there are 3 resistors here, R1, R2 and R3. Okay. Then a battery of 3 cells and a key is there. This is R1 of 5 ohm. This is R2 of 8 ohm, and this is R3 of 12 ohm. Okay, this is the battery. This is positive and this is negative. This is 6 volt battery. We already calculate there are 3 cells and one cell is 2 volts. So 3 cells has 2 into 3 is equal to 6 volt. That is, battery has a 6 volt battery. Here a key is there. Okay, then the current flow from negative to positive. That is the current flow from here. This is the diagram of the electric circuit. Then we move on to the next question that is related to this diagram. That is, by using the above diagram, putting in an ammeter to measure the electric current across the 12 ohm resistor. Putting in an voltmeter to measure the potential difference across the 12 ohm resistor, what would be the readings in the ammeter and the voltmeter? There is an ammeter here, and exchange is there is a voltmeter across 12 ohm resistor. This is the 12 ohm resistor. This across the 12 ohm resistor, a voltmeter is connected. We have to find the readings in the ammeter and the voltmeter. Voltmeter reading means the reading of potential difference. We have to find the potential difference, that is V, and ammeter reading means we have to find the current I from this. We have to calculate the current reading. That is, we know R1 is equal to 5 ohm and R2 is equal to 8 ohm and R3 is equal to 12 ohm. In a series combination, the current is constant through these 3 resistors. That is the total resistance R is equal to, here in series combination, the total resistance R is equal to R1 plus R2 plus R3. That is equal to 5 plus 8 plus 12. We will get R is equal to 25 ohm. So the total resistance of this electrical circuit is R is equal to 25 ohm, and we know the potential difference is 6 volt. V is equal to 6 volt. Then what is the current? We can find the current. We have the relation between V, I, R, that is Ohm's law. According to Ohm's law, V is equal to I into R. Here we have to find the current, that is I is equal to, that is ammeter reading. That is I is equal to V by R. V is equal to 6 by R is equal to 25 ohm. 6 by 25, it is approximately equal to 0.24 ampere. Then the next part is calculation of potential difference here. What is the potential difference across 12 ohm resistor? What is the potential difference? How can we calculate? Here we have to calculate the potential difference across R3, that is 12 ohm. Then we know the current. The current is equal to 0.24 because here the current is same through R1, R2 and R3. So the current I is equal to 0.24 ampere here. V is equal to I into R. According to Ohm's law, V is equal to I into R. I is equal to 0.24 into R is equal to 12 ohm. That is approximately equal to 2.88. The unit is volt. Okay, 2.88 volt. This is the voltmeter reading and this is the ammeter reading. The voltmeter reading across the R3. Okay. Then we move on to the second question. What is the highest and the lowest total resistance that can be secured by the combinations of 4 coils of resistance 4 ohm, 8 ohm, 12 ohm and 24 ohm? There are 4 resistors, that is R1 is equal to 4 ohm, R2 is equal to 8 ohm and R3 is equal to 12 ohm and R4 is equal to 24 ohm. Okay, we have to find the highest and lowest, highest total resistance and lowest total resistance. What is the highest total resistance? How do we get the highest total resistance R here? That is, we know by connecting in series combination. In series combination, R is equal to R1 plus R2 plus R3. That is, by connecting in series combination, we get highest value of total resistance, and by connecting parallel combination, that is 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3, we get lowest total resistance. So, by connecting highest total resistance means we get the highest total resistance secured through series combination. Series combination, that is here RS. We can denote it as in series combination RS, that is equal to R1 plus R2 plus R3 plus R4, because here 4 resistors are there, that is 4 plus R1 is equal to 4 ohm, R2 is equal to 8 ohm plus R3 is equal to 12 ohm plus R4 is equal to 24 ohm. That is equal to 48 ohm. Okay, so the highest total resistance we get through series combination, that is R is equal to 48 ohm. Then what about lowest total resistance? Lowest total resistance, we can secure lowest total resistance through parallel combination. What is the equation for parallel combination? What is the equation for the total resistance of parallel combination? That is 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3 plus 1 by R4. That is by R1 4 plus 1 by R2 is 8 plus 1 by R3 1 by 12 plus 1 by 24. We get 6 plus 3 plus 2 plus 1 all divided by 24. That is 12 by 24. That is equal to 1 by 2. The 1 by Rp is equal to 1 by 2. Then what is Rp? Rp is equal to 2. That is 2 ohm. Okay. Here the lowest total resistance we can secure through parallel combination, that is Rp is equal to 2 ohm and Rs is equal to 48 ohm. A circuit diagram is given, that is this resistor here is 6 ohm and here it is 4 ohm and here it is 12 ohm. Okay, this is 6 ohm, this is 4 ohm and this is 12 ohm. And there is a key here and there is 1.5 volt potential. Here it can be marked as AB and this is C, D and this corner is E. Okay, this is a figure. In the circuit diagram shown, calculate a question: current flowing through arms AB, AC and CDE. We have to calculate the current flowing through AB, AC and CDE. That is, we have to find the current through AB, then AC and CDE. Okay, and the B question is, we have to calculate the potential difference V, potential difference across AB, CD and DE. We have to calculate the potential difference AB, CD and DE. Okay, then C question, we have to find the effective resistance or total resistance or equivalent resistance, effective resistance of this circuit. Okay, the first question is, we have to find the current flowing through AB, AC and CDE. From AB, the voltage is constant here, that is V is equal to 1.5 volt, and in AB resistance R is, in AB there is only one resistor, that is 12 ohm, that is R is equal to 12 ohm, and the current I in AB is equal to, we know V is equal to I into R, therefore I is equal to V by R, that is V by R is equal to 1.5 by 12, that is equal to 0.125 ampere. This is the current passing through AB. Then the next one is the current through CDE. The current through CDE. Okay, what is the current through CDE? That is V is equal to 1.5 volt. Then in CDE there are two resistors. These two resistors are connected in end to end. In CDE the resistors are connected in series. These two resistors are connected in series. So R is equal to R1 plus R2. There are two resistors, that is 6 plus 4, it is equal to 10 ohm. Then what is the current through CDE? I is equal to V by R, that is 1.5 by 10, that is equal to 0.15 ampere. And we have to find the current through AC also, that is the current through AC is the current in CDE, that is the current in AC is also the current through CDE, that is equal to IAC is equal to ICDE. The current through CDE is equal to the current through AC, that is equal to 0.15 ampere. Hope you understand. Then the next question, we have to find the potential, that is the potential V across AB. Okay, what is the potential difference across AB? That is VAB is equal to 1.5 volt. Okay, the potential across AB is 1.5 volt. VAB, that is the potential across AB is equal to 1.5 volt. In the figure itself, it is clear. Then we have to find the potential across CD, that is the potential across CD, that is VCD is equal to, we know according to Ohm's law, it is I into R, that is equal to, it is across CD, I is equal to 0.15 ampere, that is it is connected in series. The current passing through CDE is 0.15 ampere. Across CD and DE also it is 1.5 ampere current passes through it because it is a series connection. So that is the current is 0.15 into the resistance. What is the resistance here? We have to find CD, that is CD. In CD it is only one resistor, that is 6, that is 0.15 into 6 is equal to 0.9 volt. The potential difference DE, that is VDE. VDE is equal to, we know the equation I into R. The current is same here, that is 0.15 into the resistance across DE is 4 ohm. That is, there is only one resistor, that is 4 ohm. That is 0.15 into 4, it is how much? 0.6 volt. That is the potential across DE is 0.6 volt. Hope you understand. Then in the third question, that is C question, it is asked to find the effective resistance. We have to find the effective resistance. Then the effective resistance of the circuit is, here there are three resistors. R1 is equal to, let R1 is equal to 6 ohm and R2 is equal to 4 ohm and R3 is equal to 12 ohm. Here R1 and R2 is connected in series. So the effective resistance here, that is we can redraw this figure as the R1 and R2 can be taken into one resistor, that is here R1 and R2 can be taken as RS. R1 and R2 can be taken as RS. This is 12 ohm and we have to find the value of RS, that is these two are connected in series combination, that is RS equal to R1 plus R2, that is R1 plus R2, that is equal to 6 plus 4, that is equal to 10 ohm. Then here RS is equal to 10 ohm. Then these two RS and these 12 ohm are connected in which combination? Parallel combination, that is it is connected in parallel. So the effective resistance can be denoted by the letter R. So the effective resistance, these are parallel combination, that is 1 by R is equal to 1 by RS plus 1 by R3. Therefore 1 by RS is 10 plus 1 by R3, it is 12. 1 by 12. Therefore on cross multiplying 12 plus 10 by 120 is 22 by 120. Then 1 by R is equal to, we get 1 by R is equal to 11 by 60. Therefore the effective resistance R is equal to 60 by 11, that is reciprocal of this, that is equal to 60 by 11, that is equal to 5.4 ohm. This is the effective resistance. If you understand these problems, here is the next question, that is there are 5 resistors here having 3 ohm here, this is 0.5 ohm, this is 0.5 ohm and this is 3 ohm. We can take this as R1 and this is R2 and this is R3 and this is R4 and this is R5. Okay, here we have to find the total resistance. That is, we have to find the ammeter reading when the circuit is closed. That is, ammeter reading means the amount of current. In order to find the current, here it is given 3 volt. 3 volt, V is equal to 3 volt, and we have to find the current. That is, here resistance. We need to find the total resistance of this circuit. We know that according to Ohm's law, V is equal to IR. We have to find the current. The V is also given, that is 3 volt. That is the resistance. We have to find the total resistance or the effective resistance of this circuit. That is, here one end of R1 is connected to R2. By taking the resistors R1 and R2, here one end of R1 is connected with the other end of R2. So, we can say that the R1 and R2 are connected in series. Here R1 and R2 are in series. So, the effective resistance is Rs. That is, Rs equal to R1 plus R2. Therefore, that is equal to R1 plus R2, that is 3 plus 3. 3 plus 3, that is equal to 6 ohm. Here we can redraw the figure, that is this is Rs and this is 3 ohm, that is R4. Okay, then there is ammeter and there is a key here. Okay, this is A, B, C. That is, Rs is equal to, we have calculated R1 and R2. The total resistance of R1 and R2 is Rs, that is Rs is equal to 6 ohm, and this is R3, that is 0.5 ohm, and this is R5, that is 0.5 ohm. This is R5 and R3. Okay, then here we can conclude that these Rs and R4 are connected in parallel. Here common points, that is from the figure itself it is very clear that Rs and R4 are connected in parallel. R4 and Rs are connected in parallel. Okay, that is, we can write R4 and Rs are connected in parallel. That is, 1 by Rp is equal to 1 by R4 plus 1 by Rs. That is, 1 by Rp is equal to 1 by R4, that is 1 by 3 plus 1 by 6, that is 9 by 6 into 6 plus 3, that is 9 by 18, that is approximately equal to 1 by 2. That is, 1 by Rp is equal to 1 by 2. So, Rp is equal to 2 ohm. Okay, then we can again redraw this figure as we can mix these two into one. That is, these two are calculated into the total resistance of these two is 2 ohm. That is Rp. That is we will get, this is 0.15 ohm. This is Rp and this is 0.5 ohm. Then these two are connected. Ammeter. Okay. Then these two are combined into one, that is Rp. Rp is equal to 2 ohm. Then here as well 0.5 ohm R3, and there is also R5, that is also 0.5 ohm. Then in the figure itself, the one end of R3 is connected with Rp and the other end of Rp is connected with Rs. That is, here it is connected end to end, that is R3, Rp and R5 is connected in series. Therefore, the total resistance R is equal to R3 plus Rp plus R5, that is equal to 0.5 plus 0.5 plus 2, that is 0.5 plus 0.5, 1 plus 2, that is 3 ohm. That is the total effective resistance of this figure is 3 ohm. You have to solve such a problem in step by step like this. Then you will get the total effective resistance of this figure. Here the parallel combination and series combination are mixed together. You have to solve it by step. That is, here R1 and R2 are connected in series. Then we calculated the total resistance here, that is Rs is equal to 6 ohm. Then we redraw it as Rs. These two are combined to form Rs, that is the total resistance of R1 and R2 is Rs, that is 6 ohm. Then we get this Rs and this R4 are connected in parallel. Then we again solve it into Rp, that is 1 by Rp. Rp is equal to 2 ohm. Then we again redraw it as Rp. This instead of Rs and R4, we connected Rp of 2 ohm. The total resistance of this is 2 ohm, that is Rp. Hence, these R3, Rp and R5 are connected in series. Then we get R is equal to 3 ohm. The total effective resistance is 3 ohm. Here we have to find the current, that is I is equal to V by R. Here V is equal to 3 volt by R. The effective resistance, that is 3 ohm, that is 3 ohm, that is equal to 3 by 3, that is 1 ampere. So here the current flow is, the ammeter reading is 1 ampere. Okay, here the ammeter reading is 1 ampere. These are the problems related to resistors are connected in series and parallel combination. Hope you understand. Then we will continue in the next class. Thank you.